We're going to take a look at part 4 of the problems. These are the same problems that we did in part 3, only now we're going to say that they were at the beginning of each period, the series of payments, as opposed to the end. And so here we're talking about annuity due. So if there is a series of payments and they happen at the beginning of each period, they become an annuity due rather than a ordinary annuity. So here we go. You just won $1 million on the lottery. If you choose payments over 20 years, $50,000 a year, only now we're going to get it up front. What is the cash value, the present value, that if they gave you a lump sum right now would equal the $50,000 a year for 20 years, assuming that a 6% interest rate is used. So if we did a timeline, we would show the rents received, $50,000 for 20 years, and we have I of 6%, and we want to know the present value. So if we want to know, if we want or need the present value, we have an annuity, okay? We're going to use PV equals R times, here we do have a table for this, and that is table 5. Okay, so PV equals 50,000. Let's see. Okay, so now we're going to take a look at table 5 for 6% and 20 years. And we'll find table 5. Okay, present value of an annuity due. Okay, and we want 6% and 20 years. Okay, so here we go, 12.158116. 12.158116. Okay, so we put that into our calculator. Times 50,000. And that is equal to 607,906. Okay, so once again, 50,000 times 12.158116. Oops. All right, let me do this again. Getting a different answer. 50,000 times 12.158116. 607,906. Okay, and then let's just double check that I have the correct 2012.158. Yeah, okay. All right. So that would be the present value of that $1 million. Okay. It's $1 million, but it's spread over 20 years. So it's not really worth $1 million. It's only worth 607,906. That's if we get the payments at the beginning of each period. Okay, let's take a look at the next one. Here we have Richard, 65, about to retire. It's $500,000 saved right now to supplement his pension and Social Security, and would like to withdraw it in equal annual dollar amounts so that nothing is left after 15 years. So he wants a series of payments to come out of that account. Okay, and so how much does he have to withdraw each year if he earns 6% on his money? Okay, so here in our timeline, we have a present value of 500,000, and our R is what we want to know. How much is he going to take out? Okay, we have 6% on our I and 15 years for our N. Okay, so, and this is supposing, again, that he's going to take out the money at the beginning of each of the 15-year periods. Okay, so again, we have a, because we either have or need the present value, and we have an annuity due, so we've got PV equals R times table 5. Okay, in this case, we know our PV, our present value is 500,000. What we want to know is our R. Okay, our table 5 we need for 6% and 15 years. So we're already in table 5. We'll look at 6% and 15 years. 10.294984. Okay, now we have to get the R by itself. So we're going to take each side of the equation and divide it by the 10.294984 so that we can get the R by itself. Okay, so on the right side, that'll wipe itself out and leave the R by itself. And then on the left side, okay, so we're going to take our 500,000. We're going to divide by 10.294984, and we get 48,567. Okay, so he can take out $48,567 each year for 15 years, and then at the end he will have zero left. Okay, this is the one that we don't have 40 years in our ebook tables. So we'll do the 20 years and 30 years. Okay, she started at 22 years old, plans to put 5,000 in annually, earning 8%. And how much would she have in 20 years? So here we want the future value. And since she's going to put this $5,000 in at the beginning of each year, this would be the future value of an annuity due. So when we have the future value of an annuity due, we're going to use table 2, but then we're going to have to modify it. Okay, so let's get the table 2 number. And we've got, let me see, 8% interest, and we're going to start with 20 years. Okay, so we take a look at table 2. Okay, and we want 8%. 20 years is 45.76. 1964. 45.76, 1964. Okay, so that is our factor from table 2. Okay, then we're going to have to multiply that times 1 plus the interest rate. So the interest rate is 8%, which is 0.08, so 1.08. And we're going to multiply that times the 45, that factor that we got from the table 2. So 45.76, 4 times 1.08. That gives us 49.42292, and I'm just rounding it off there. Okay, so now we can say that our future value equals our R, which is 5,000, times our table 2 modified, which is 49.2292. Oops, nope. 49.42292. Okay, and we'll put that into our calculator. We got 5,000 times 49.42292. And that's 247,115. Okay, so that's how much she would have in the account at the end of 20 years. Okay, now if she wanted to go to 30 years, okay, so for 30 years, we have to look up and that was 8%. Only now we're going to look up 30 years in table 2. 8%. 30 years. We need to go down a little more. Okay. 113, 28, 32, 11. 113, 28. Okay, so that's our factor from table 2. And we need to multiply that times 1.08. And we get 122.3458.7. I'll round it off there. So now we can put that in. FV equals 5,000 times 122.34587. And that's 611, 729. Okay, so again, just like in problem 3, just that little bit of that difference of letting it sit in there 10 more years, and she's, way more than doubled her amount of money by waiting the extra 10 years. Again, I will post the answer for 40 years as soon as I get a chance. Okay. Here we go with the fourth one. Okay, and this is how much will, if she waited 10 years before she starts saving, how much will she have when she reaches 62? So that is a 30 years as well. And so that would end up being the 611, 729. Okay, we are putting in 5,000 a year. Now this one, she is starting later, but also waiting till later. So she's starting at 32 and quitting at 62. In this one above, she's starting at 22, but quitting at 52.